In this video, we're going to take a look at the Excel project for week 4. There's really not any new Excel features that we're going to do. Instead, we're going to try and do some higher order thinking, critical thinking, and planning to use Excel to create your own Bayes theorem calculator. So that's what we're going to do. We're going to create a calculator for Bayes theorem where we can type in the information we're given and have Excel automatically calculate all the other situations. This will kind of give us a setup so that we can play with an if-then analysis. We do that a lot in Excel where we program it out and we say, well, what if this value was 7? Well, what if this value was 8? How does that change the bottom line? And this can really help in our decision-making process for many different business applications. This is the file that we have for the project for this week. You'll notice that there are a couple boxes that are yellow. These yellow boxes are the boxes where we will type in numbers. Type in numbers into the yellow boxes, and then all the other cells on here, cell C4, cell C8, C10, C12 through 15, and C17 through C20 are going to be formulas that you have to figure out how to type the formula. What we're doing is we're looking at a product where some of our imports are made in the USA and some are made abroad. And because nobody's perfect, some of them are defective. Now, there's a different defective rate out of the USA and a different defective rate out of the abroad. So we might know the probability that something is made in the US is about 0.25. Maybe a quarter of them are made in the US. And the probability that something is made abroad then would be the opposite of that. You're going to have to find some way to make this Excel cell automatically calculate that based on what we typed before. Remember, to start any calculation, you always have to type in equals, and then select the cell you want to refer to when you're ready to refer to it in the formula. What I want you to do is figure out what formula you type in here. Now I'm going to type the wrong formula here to show what I mean. So I'm going to type 7 times and then the previous cell. That's the wrong formula, by the way, but that's kind of how I can type in 7 times that number. And when I hit enter, now that is automatically going to calculate 7 times whatever's in there. If I change that probability value to 0.6, it automatically updated to 4.2. That's what you want this cell to do. Now again, that was wrong. You need to figure out equals what is the correct formula that if there is a 0.6 made in the USA, how do we calculate the made abroad? The next part is, given that it's made in the USA, what's the probability that it's defective? Maybe USA parts are defective 10% of the time. And if it's given abroad, the last yellow cell, let's say it's defective 0.3% of the time. You should be able to calculate all of the other values based on what's in here. It will probably help a lot to draw yourself a tree diagram. So to help draw a tree diagram, get a pen here, you're going to want to show the branches off first initially. Was it made in the US or was it made abroad? You might write down what cell numbers are in what places to help you with that. And then from there you can say, well, was it defective or was it good? You know, start making your tree diagram. And write in the cell numbers so that you know what gets multiplied or to get your probabilities coming out. Because each of these are going to represent the probability. This represents the probability that it was made in the US and defective. The probability it was made in the US and it's good. The probability that it was made abroad and it's defective. The probability it was made abroad and it's good. And so you can start calculating the probabilities the spreadsheet is going to ask you to calculate. So hopefully this helps get you started on the project. It is supposed to be a little bit trickier. It's supposed to make you think about what we're multiplying together, what we're adding together, what we're subtracting, how are we actually calculating these probabilities. Good luck to you, and let me know if you have any questions.